So we're back. We're going to be looking at stretches in the, or sorry, not stretches, reflections in the y-axis. So now rather than folding your Cartesian plane down along the x-axis, you're folding it vertically along the y-axis. So again, let's put a point in our, let's put point A here. And when we reflect A about our y-axis, we can see that A is 1, 2, 3, 4 units away from the y-axis on the right-hand side. So the reflected point is 4 units away from the y-axis on the left-hand side. And so we've now reflected point A about the y-axis. And something I didn't mention in the last video is that when we're reflecting about the y-axis, notice that the y value remains the same. So if we look at this point A, we've got an x component of 4 and a y component of 1, 2, 3, 4, 5. And if we look at our reflected point A prime, we can see that that's -4, but our y component has stayed the same. We haven't moved this point up or down, we've moved it left and right. And conversely, when we're reflecting about the y-axis, or sorry, the x-axis, the x component remains the same, and it's the y component that changes. So now let's reflect this graph here. We'll call this f of x, and we'll reflect it and show that reflection using a red pen. And so this point A gets reflected here. So this is our A prime. Notice that B doesn't change because it's no, oops, and I've made a mistake here, so just let me correct myself. And it'll just take me a minute to put this back together here. Just gonna show this even more clearly, and because I didn't take the time to count, I was estimating, and that estimating led me to make a mistake. So A is 1, 2, 3, 4 units from the y-axis on the left-hand side, and so A prime is going to be 4 units on the other side, so 1, 2, 3, 4, and notice that I'd placed A in the wrong location, so that's A prime. My B point here remains unchanged, and I have C right there, and my C actually is 3 points or 3 units away on the right, so C prime, or the reflected C point, is here. And now it's starting to look a little complicated, so we're going to take a minute and just connect up the lines that we've already drawn so that we can see what shape we're making. So A prime will attach to B, and we have B. Notice B and B prime are the same point because they are they're actually referred to as invariant points, and these are the points that points on the function that exist on the line that we're reflecting around. And we're going to then go from B to C prime here, like so. I'm going to go to D, and D is 1, 2, 3, 4, 5, 6, 7 units to the right, so D prime, or the reflected prime point, is 7 units to the left. 1, 2, 3, 4, 5, 6, 7, and so here's our D prime. And I'm just going to redraw this line here, so just let me take that out, and we're going to try that again. So we go from B to C prime, and then from C prime to D, and finally F sits here, and if we count, this is 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got 7, negative 7 to here, 1, 2, 3, 4, 5, 6, 7, 8. So our reflected point F, or F prime, exists there, and we can see that that red is our reflected function. And when we're reflecting around the y-axis, notice what's changing is we're going from a positive x here to a negative x, and conversely, if you were negative x, it becomes positive. And so rather than the function changing signs, it's the output changing signs, it's the input. So we have the when we reflect on the y-axis, results in a negative x value. And so we end up with that negative being inside the function, and that tells us we're reflecting on the x-axis, or sorry, on the y-axis. Let's look at another equation, or another function. I'm going to draw another Cartesian plane down here, and we're going to look at a quadratic like we did in the last graph, and this time our quadratic equation is going to be y is equal to x minus 1 squared minus 3. So this tells us that we have a vertex of 1 and negative 3. So our vertex is at positive 1 and negative 3 right here. And I'm just going to sketch a few points so that I can do maybe a slightly better job graphing the shape of this. So here we go like so, and like so. So this is our f of x, our original function. Now we're going to reflect this function about the y-axis. So let's look at our vertex. It's 1 away from the y-axis on the right, so we make it 1 away on the left. Here we've got our y-intercept, it's our invariant point, and then we have a point here. I'm going to call this point A just to make it easy, and it's 2 away, and so our reflected point A is 2 away on the other side. And now this x-intercept is going to be reflected, and it'll come here, and I'm not calculating that exactly, so we can draw this point like so, and we can go up like so. And so this x-intercept and this x-intercept are reflected, and I've kind of stretched that out. I wasn't as careful as I should have been in the graphing, but you can see how it's been reflected. What I want you to notice is we can, because we know this vertex, we can write this reflected equation. The vertex here is negative 1 and negative 3, and so we have, sorry, I apologize, my recording just completed converting, and so it pulled up my recording program. So as I was saying, we're writing the equation here. Because we're to the left, this becomes x plus 1 squared, and we're still down 3. And so this looks kind of odd, but okay, as I was saying, we can write the function from our understanding of where the vertex is. But you might be saying, well, you talked about having this negative x, or the negative input. That doesn't look like you've got a negative x. And so the way to show that these two are the same, when I put in a negative x and when we write the equation, what we do is we expand it out. So if I'm going to take this equation and expand it out, I have x plus 1 and it's squared, so that's x plus 1 times x plus 1, and then I subtract 3. Using FOIL, I get x squared plus x plus 1 minus 3. When I simplify this, I get x squared plus 2x minus 2. Okay, and so this is our reflected, or the equation of our reflected function. Here, with my original equation, I'm going to start here. Remember that we input a negative x, so to change it. So to reflect this, I'm going to take y is equal to bracket, and I'm inputting a negative x minus 1, and I'm squaring that minus 3. So when I expand this out, I have negative x minus 1 times negative x minus 1 minus 3. When I use FOIL, that's negative x times negative x, which gives me x squared. Then I have negative x times negative 1, which gives me positive x. Again, negative x minus 1, which gives me positive x. Negative 1 times negative 1, positive 1 minus 3. When we simplify this, we end up with x squared plus 2x minus 2. And we can see that when we write the equation from the graph, and when we write the equation inputting that negative x, or using a negative x to indicate the reflection about the y-axis, we end up with the same equation. Next, the next videos will be on vertical and horizontal stretches. Until then, bye for now.